Okay, so in this example, they're asking us to describe a time distance graph. So here we have a table here, and it's split into segments. Now a segment on a graph is going to be a section of linear line. So you can tell here this is O and A, so this is one segment until it changes direction. This is going to be the second segment, AB, then BC, CD, and DE. So this graph is asking us to describe a day trip from Winnipeg to Winkler, Manitoba. So in this case, we're traveling from Winnipeg to Winkler. The distance described here is the distance away we are from Winnipeg. So you can tell as the graph goes up, we're getting further from Winnipeg, and then as the graph descends here, we're getting closer to Winnipeg. And it tells us the distance between Winnipeg and Winkler is 130 kilometers per hour, or 130 kilometers. So the first segment is going to be segment OA. So in segment OA, the graph goes up, it increases, and to the right. The graph is always going to go to the right when we're dealing with time graphs because time always marches on, it never stops. So as time increases, the distance from Winnipeg increases. And that makes sense. As time goes on, the distance from Winnipeg increases because we're traveling away from Winnipeg. So in the first hour, this hour right here, segment OA, the car leaves Winnipeg and travels approximately, we've traveled from 0 kilometers to, it's right here, so that's about 65, because between 60 and 80 would be 70, and between 70 and 60 would be 65. So approximately 65 kilometers towards Winkler. Next section is going to be AB. The graph is, in AB, the graph is horizontal. The graph is horizontal, and what that means is our distance is neither increasing nor decreasing. So as time increases, the distance stays the same. That makes sense. We're not increasing the distance or decreasing the distance. So what that means is the car stops. We've stopped the car for approximately, here from 1 hour to, this would be 1.5 hours, so that's between that, so about 15 minutes. Next section is going to be BC, this section here. And BC, we notice that the graph goes up and to the right, so it goes up and to the right. So as time increases, the distance increases. The distance from Winnipeg increases because we're going from about 65 kilometers all the way up to 130 kilometers. So the car travels approximately, well, if we went from 65 kilometers to 130 kilometers, this is 130 kilometers here between 120 and 140, that's 65 kilometers towards Winkler. And obviously if Winkler is 130 kilometers from Winnipeg and we've traveled 130 kilometers away, we can assume that we've arrived at Winkler here at point C. The next section is CD. The graph at CD is completely horizontal, so our distance is neither increasing nor decreasing, horizontal. So as time increases, the distance stays the same. That means that the car stops again for approximately, and it looks like we were in Winkler from 2 o'clock or from 2 hours to 4 hours, so that's 2 hours, but it's asking it in minutes, so we can say 120 minutes. The next section is DE. And DE, we can tell that we're obviously traveling back to Winnipeg. We've gone from Winkler here all the way to Winnipeg in one straight shot. So the line is going down and to the right. So as time increases, the distance from Winnipeg is decreasing because we're coming back to Winnipeg. So it decreases. So the car returns to Winnipeg and takes, let's see how many hours it takes. We go from 4 o'clock, we start returning all the way to 6. So that's 2 hours to travel 130 kilometers. Because we started at 130 kilometers here and went all the way to 0 kilometers in one straight shot. Pause the video here. See if you can describe exactly what's happening in each segment of the graph, then come back and we'll go through the answer. Okay, so here it is. I'm not going to go through it in detail. So feel free to pause the video and double check your work, but we will move on here. Alright, so our final step here is to draw a graph. Now we're going to sketch your graph if they've given us the description of what's going on. So we're actually doing the opposite of what we've done up here. Here we looked at a graph and gave a description. Now we're given a description and we're asked to draw the graph. So let's see here. Samuel went on a bicycle ride. He accelerated until he reached a speed of 20 kilometers per hour. So I know that my graph is going to be dealing with kilometers per hour. So that's probably going to be one of my sets of data. Then he cycled for 30 minutes. So right there, now I'm going to be dealing with time. So I know one of these axes is going to be speed in kilometers per hour, and one of them is going to be time. Now we talked about how time is almost always the independent variable, which makes kilometers per hour the dependent variable. And the independent variable is always going to go along the bottom. So I'm just going to write that in here, time, and you'll get used to that. You're always going to see time on the bottom, so it'll become second nature at a certain point. And then we'll have speed here. Speed in kilometers per hour. And time is going to be in minutes because they give it to us here. Okay. So as I'm reading this, what I like to do is I like to split up the description into legs or into segments. So I'm actually going to break this up. So Samuel went on a bike ride. He accelerated until he reached a speed of 20 kilometers. Break, because that's going to be one segment. Then he cycled for 30 minutes at approximately 20 kilometers. Break. Samuel arrived at the bottom of a hill and his speed decreased to approximately 5 kilometers per hour for 10 minutes. Okay, so I'm going to stop it here. So he decreased to approximately 5 kilometers an hour, and then for 10 minutes as he cycled up the hill. Boom. He stopped at the top of the hill for 10 minutes. There. So my graph is going to have 1, 2, 3, 4, 5 segments. Now, sketch a graph of speed as a function of time. Label each section of the graph and explain what it represents. So, my time here, how much time has passed? I need to know exactly how much time has passed in total. So I'll look, he cycled for 30 minutes, and then for 10 minutes, and then for another 10 minutes. So we're looking at 30, 40, 50, and I'll add a bit more. So let's say that it's approximately an hour. So I need to find my scale here. So I'm just going to say every second unit will be 10 minutes, 20, 30, 40, 50, 60, like that. And it's nice to try to use as much of the graph as possible when you're doing this. So choose a scale that fills up at least more than half the graph. So speed, well, to know how much speed I need to put along this axis, or the highest speed, I need to find out what his maximum speed was. So he reached a speed of 20 kilometers an hour, and then he went back to 5 kilometers an hour. So his top speed was 20 kilometers per hour. So let's see, maybe I'll just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's not quite 20 units here, lines here, so I can't make every line 1 kilometer. But I can make every line 2 kilometers. So let's say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I'll add a few more. 22, 24. There. And I'll do that here too. So 60, 70, 80. Good. Okay, here we go. So we start here at time 0. And let's start filling this in. So he accelerated until he reached a speed of 20 kilometers per hour. Sam's speed increases from 0 to 20 kilometers per hour. So the line must go up because his speed is going to increase, and to the right because time is always passing, so it's always going to go to the right. So Sam cycles, this is going to be segment, we'll call this segment OA because this is going to be the first segment. Sam cycles uphill at approximately, oh sorry, that's the next one. Okay, so we'll finish here. So we need to go from 0 to 20 kilometers an hour, and we'll do that with a pretty steep line because I don't think it takes him very long to get from 0 to 20 kilometers an hour. So let's say that he does it in like this. We'll say he does it relatively quickly, maybe 2.5 minutes. There we go. All right, the next step. Sam cycles at 20 kilometers per hour for 30 minutes. So his speed stays the same. So the line is horizontal. It has to be horizontal because the speed is not changing. So it's a horizontal line, and he's there for 30 minutes. So here I'm at, remember this is 10, which makes this 5, which makes this 2.5. So 10 minutes would be right here. There we go. So, oh, sorry, that's 30 minutes. So I need to increase that. So 30 minutes would be 32.5, right about there. All right. Now Sam's speed decreases to 5 kilometers per hour. So the line goes, if he's decreasing speed, the line's going to drop. So it's going to go down and to the right because it's always going to the right because time is always passing. We can't stop time yet. So we start here, and he probably decelerates pretty quickly. So let's say it takes him 2.5 minutes to decelerate, or somewhere around there. And we'll go 5 kilometers per hour, right between 4 and 6 right here. There we go. Sam cycles uphill at approximately 5 kilometers per hour for 10 minutes. His speed stays the same. So the line is horizontal. And for 10 minutes. So this is 50 minutes here. So we're going to go from 50 minutes. Oops, sorry, this is 35 minutes. We're going to go from 35 to 45. Oops. And that should be like that. There we go. So that's from 35 minutes to 45 minutes. Now, Sam slows to 0 kilometers per hour. His speed decreases. So the line goes down and to the right, because again, it always has to go to the right. So we'll say he does that pretty quickly. We'll go down to here. And then Sam remains stopped at 0 kilometers per hour for 10 minutes. So if he stopped at 0 kilometers per hour, the line is horizontal. So the line would be right about there. So that's from approximately 47.5 minutes to 57.5 minutes. And that's it. So try one on your own. Pause the video here. Come back, and then I'll show you the answer. Okay. Here we go. Again, I'm not going to go through this in depth, but this is going to be a chance to check your answer. If you're a little confused, you can go back and maybe watch the example again. 23. We'll see you in class for the practice work.